All right, today we are starting 2.1 and our section is titled What is a Function? And by the end of today, we're going to be able to find the domains of functions and evaluate functions given values and expressions. Okay, so a little bit of this is going to be review, and then we're going to be extending some concepts. So we're going to be talking about some piecewise defined functions. So those are just defined by different formulas on different parts of its domain. Remember, the domain is just all of your possible input values, okay, or your x values. Once you guys have that written down, if you glance at example 1, it says we're going to evaluate, and we are given a piecewise function, and we have to find f of 1, f of 3, and f of 5. Okay, if you remember how to find f of 1, please go ahead and do that. Okay, so think about what f of 1 means. What do we have to plug in? Okay, so when we are evaluating, we just have to find which part of the domain the value fits into. So for f of 1, it's going to fit into x is less than or equal to 3. So all we have to do is substitute 1 in for x. So instead of 3 minus x, I have 3 minus 1. That's going to be 2. And then we would write our answer in function notation. So f of 1 is equal to 2. Okay, for f of 3, these both contain 3, but this one is the equal to, so we're going to use that first equation again. So 3 minus 3 is going to be 0, so f of 3 is equal to 0. Okay, and then f of 5 is going to fall in x is greater than 3, so f of 5 we're going to plug in for x. 5 squared we know is 25. Okay, and this is another no calculator section. 2.1 is. And then later this week, we actually will be using calculators. All right, so this is, what if there was no x in the expression and you just had a constant? How would you evaluate? So that would look something like this. Okay, if you had a f of x was equal to 10, if x was less than or equal to 3, or 2, if x was greater than 3. Okay, so if you had to find f of 1, do we know what our solution would be? It would equal 10. Again, if we did f of 3, that would equal 10. If we found f of 5, that would be 2. Yeah, because it's going to be on that interval. Okay, so how would you evaluate if you just had a constant? Your solution is always going to be that constant if there's no x term. Okay, so if there's no variable, okay, there's nowhere to plug in the 1. Okay, all this is saying is, oh, I would have to evaluate on that first interval there. Okay, so if there's no variable, you are just going to keep your constant term. Okay, and then we are going to use the function to evaluate the indicated expression, and we are going to simplify it. Okay, so we're evaluating, and then we have to make sure that we simplify if we can. Okay, so this time we're evaluating f of a plus h. So it's not a number. Before we had f of 1, f of 3. Now we have f of a plus h. All that means is we are going to substitute a plus h for the term of x. And sometimes the x occurs more than once. That means you would plug it in multiple times. So one thing I like to do is I like to write the expression without x in it and with parentheses. So it's 3x squared plus 4 times x minus 1. And then I can just go back and plug in my a plus h for x. Now from here, we have to keep in mind our order of operations. So we don't want to multiply by 3 first, because in our order of operations, we do exponents before we multiply. So this would be 3, and a plus h squared, remember, is a plus h times a plus h. So don't just write a squared plus h squared. That's incorrect. We are going to have to FOIL. So let's do all of that first. So if you're FOILing and you're doing a times a, you get a squared. AH plus AH would be 2AH. H times H would be H squared. Now we can distribute the 3. So it's 3a squared plus 6AH plus 3H squared. So times 3 times 3 times 3. And then the 4 times a plus h, I am going to distribute. I'm just going to put it here, 4a plus 4h. And then don't forget the minus 1. All right, and then I'm going to look for like terms. This is a squared. Don't have anything that matches that. H squared, and a number. So you can't combine any like terms in this particular case. So we're going to leave it. If you do have like terms, then you will simplify. All right, and this f of a plus h, and what we're doing in the next question, where we're evaluating this f of a plus h minus f of a divided by h, this is going to come back around again at the end of the year. This actually has something to do with finding limits. And so it is, I know it's a little different to have all of that together, but it is going to tie back to something else. So they give you a different value of f of x, ask you to evaluate. What we're going to do is we're going to find f of a plus h first, and then f of a, and then we're going to substitute it in. So based on what we did above, I want you guys to find f of a plus h using this equation. Okay, so you're going to plug that in, but to your new equation that you have there. And then if you finish that, you can also write down what your f of a is. All right, and let's check to make sure we all got the same f of a plus h. Okay, and then it's f of a plus h minus f of a. So f of a is just going to be this exact same trinomial, but instead of x, we want to put the a in there. Okay, and so when we plug that in, write it again. Okay, so when we plug that in, we want to make sure that we distribute the negative. Okay, so this is 2a squared plus 4ah plus 2h squared plus 4a plus 4h minus 1. I like doing these on the side because I just think it's a little bit easier to manage. Okay, your book kind of shows it all at once where they put all of this on top minus that value. And then when you distribute the negative, just make sure it goes to all three of those terms. Okay, so this becomes negative and this becomes negative, but this negative is going to become positive. So now we're going to simplify. 2a squared and negative 2a squared, those are going to cancel. Okay, 4ah, nothing to combine that with, so we're going to keep it. The 2h squared has nothing to be combined with. I have 4a and negative 4a, so those are going to cancel. Nothing to combine with 4h, and then I have negative 1 and a positive 1, and that's all divided by h. Okay, so when you're going to the next step, there's two ways you can do it. What you'll see the textbook do is they factor out an h, and then they'll do division. You could do division in this step, just make sure you divide everything by h. Okay, so the only reason why I'm factoring out the h only is because that is going to cancel out with the denominator. Okay, and then like I said, you can also just divide everything by h and go straight here to 4a plus 2h plus 4. But this is going to be your final answer. You do not need to factor out the GCF because we're not leaving this in factored form. You only have to worry about the GCF if you're trying to write something in factored form. Okay? All right, let's check out what we're doing next. Any questions for me on that? Okay, so for part C, we are still evaluating and simplifying. We're given an f of x, and we have to find two things here. Okay, so the first thing that we're going to find is f of x plus 2. Okay, and then this is f of x plus f of negative 2. So there's two different things we're going to find. Okay, so with the first one, if we do f of x plus 2, that means instead of x, we have x plus 2 plus 4. I generally plug them in with the parentheses. That way I don't miss anything if I have to multiply. But here, there's nothing else in front of it, so you can just combine the plus 2 and the plus 4 to get x plus 6. Okay, that's going to be your final answer. And then for this one, if you do f of x plus f of negative 2, f of x is just x plus 4. And then you keep this plus here. F of negative 2 is negative 2 plus 4. Okay, so this becomes 2. And then you get x plus 6 again. We're not always going to get the same thing. Okay, for this one, it's just so happens the conditions were right to both get x plus 6. Okay, and the big thing there is following your order of operations. All right, and then the second set of our notes is going to deal with domains and applications. We have talked about domains already this year, so some of these you're going to be able to do without me even telling you how to do it. And we're going to write these in interval notation. Use the same interval notation for your notes because that's how you'll need to know it for your quiz. Okay, so when you're finding the domain, let's talk about the restrictions. What are the two things we're looking for restrictions? When we have the domain. What can't we have? Yes, so fractions and square roots or any even root. So with fractions, we want to make sure the denominator is not 0. And with even roots, we have to make sure the radicand is greater than or equal to 0. So it can't be negative. Okay, so you guys can go ahead and you can do A without me. Try that. You can also try C. But I would like to do B together. Okay, so I'm going to give a second to try that. Alright, so when you have a fraction, the first thing you have to do is set your denominator equal to 0 and solve, because we know that it can't be 0. Okay, that's where your restrictions are going to be. So we're going to factor. So we're going to factor out the GCF, which is x, which is going to leave us with x plus 1 times x equals 0. So here you have as x equal to 0. Here, if you had x plus 1 equals 0, you would get x equals negative 1. These are going to be the two values that x cannot equal. It can't be 0, it can't be negative 1. When you're setting this up in interval notation, you don't have to do the number line, but if you've been having some trouble setting them up, I do think it's helpful so you can see your intervals. This is your first interval, the second interval, the third interval. So if it can't be a 0 or negative 1, it's going to be negative infinity to negative 1, parenthesis because it can't equal, in union with negative 1 to 0. Again, you're going to have the parentheses because they can't be equal to that value. And then 0 to infinity. Okay, so that is going to be your final answer. Okay, the other one I said that you could do without me is C. C actually has two things going on. It has both the fraction and the radicand. So if it has both, or root, okay, both fraction and square root. So in that case, you're going to have to take the radicand and just set it greater than 0. If it's both, it won't be equal to anymore. So it's just x plus 2 is greater than 0. Can't be equal to. So that means x is greater than negative 2. And then we just have to write that in interval form. Again, if you need to see the interval, the number line is helpful. So you can see it starts at negative 2, does not include it, and it goes to infinity. So that's going to be your final answer. Okay, now those are skills we've done before. B is going to be something new. So we have an even root, it's a square root. If it's not an even root, what is going to be your domain? So if it's an odd root, right? Can we take an odd root of a negative? Yeah, we can take the cube root of negative 8, it's negative 2, right? So if you do come across an odd root, it's just going to be all real numbers. Okay, if it's an even root, we take the radicand and we set it greater than or equal to 0. Okay, it's not on the bottom of a fraction, so we're going to take 16 minus x squared and set it greater than or equal to 0. Okay, now what you can't do is you can't just move the x squared, take the square root, do the plus or minus 4. Okay, that can help you get your key values, but this is a non-linear inequality. So if you have a non-linear inequality, which is what we did in 1.7, to solve these, you have to make your table. So you have to use your table with your intervals. Okay, this one might not be as obvious because it's not a trinomial, but you could have a trinomial. This is the difference of two squares. So you're going to factor. So whether it's a trinomial or a binomial, you're going to factor. So 16 minus x squared is going to factor into 4 minus x and 4 plus x, or vice versa. You could have 4 plus x and 4 minus x. Okay, so then your key values are what make those 0. Okay, so you could plug in 4 to make the first one 0. You could plug in negative 4 to make the second one 0. And then we're going to set those up on our number line to make our table, to make our number line table. Okay, so the negative 4 has to go first on the number line. Okay, so we have negative infinity to negative 4. Because it's equal to, you'll have a bracket. Negative 4 to 4 with brackets, and 4 to infinity with brackets. Okay, so hopefully you remember when you do this, you have your columns here. You're going to put your factors on the side, so your factors are 4 minus x and 4 plus x. And then at the top, I'm just going to put my test values. Okay, and you guys can pick your test values and do that. Okay, so again, you're going to be using the table if you have a nonlinear inequality. So that could be a quadratic, a cubic, or a rational function. So anytime you encounter those, that's when you're going to need to use your table. Okay? So I chose negative 5, 0, and 5 for my test values. So if I plug in negative 5, minus a negative is plus, so this becomes positive. This is a negative. The product is negative. If I plug in 0, I get a positive and a positive. The product is positive. Here I get a negative and a positive, so the product is negative. Now for this one, do I need the negative solutions or the positive solution? Positive, why?
Greater than 3.
Yep, greater than or equal to 0. So really, when you're doing the domain, you're always going to pick the positive because you're always trying to find where it's greater than or equal to 0. Okay, so anytime it's greater than or equal to 0, you're going to pick the positive. And so you're going to have the interval of negative 4 to 4. Okay, for our next example, we have a story problem. Now this story problem, we're going to do without a calculator because we'll be able to do that pretty easily. But on your homework, if you're dealing with decimals and some larger numbers, you can use your calculator on that, okay? You're going to see that this one is just going to be with different rules that you remember. So it says the cost C in dollars of producing X yards of a certain fabric is given by the equation C of X is equal to 1500 plus 3x plus 0.02x squared plus 0.0001x cubed. And then we have to find C of 10 and C of 100. So let's start with C of 10. So you have the 1500 plus 3 times 10 plus 0.02, 10 squared plus 0.0001, 10 cubed. So we're just going to go over some of the rules about powers of 10 and how to move them along. Okay, so we know 3 times 10 is 30. We know 10 squared is 100. And we know 10 cubed is what? And we know 10 cubed is 1,000. Okay, now when you are multiplying by 100, that means you're going to move the decimal how many places? Yeah, how many? 2. It's the same as the number of zeros. So if you move this 2 spots, it just becomes 2. And if it's 1,000, you're going to move it 1, 2, 3, so it becomes 0.1. So when we add all those together, the 1500 plus 30 plus 2 is going to be 1532.1, but since we're writing it in terms of money, 0.1 is really how much? 10 cents, right? So you're going to put the 0.10. Okay, and then I'm going to put the C of 100 over here. So we still start with the 1500. And then any place we see an X, we're going to put in 100 there. Okay, so then we have 300 plus. Now when you square 100, do you guys know what happens? Like how many zeros you get? That's your, it's what? There will be 2 more. Yeah. Yeah, so 2 more total. So altogether you'll have a 1 and you'll have 4 zeros. So you have 100, you're going to add the 2 zeros on. It's 10,000. Okay, and then for 3, so here you had 2 zeros, you doubled it. Here you have 2 zeros and you're going to triple it. So there's going to be how many zeros if you triple? 6. 1, 2, 3, 4, 5, 6. Okay, and then the way that you move it is based on the zeros. So for 100, we moved it twice. For 1,000, we moved it 3 times because there were 3 zeros. So if there's 4 zeros here, we're going to move it 4 places. If there's 6 zeros here, then you can move it 6 places. Okay, so if I do that, 1, 2, 3, 4, that's going to become 200. Good. Okay, and then let's move this 6 places. So 1, 2, 3, 4, 5, 6. In the blank spaces, you put the zeros. So we're adding 1500, 300, 200, which 1500, 300, 200 is what? $300 and $200 is 500, 500 plus 1500, 2000, 2000 plus 100. Yep. Okay, so again, that's when we can do without a calculator. When you're working on your homework, if you have some more complex decimals, feel free to use your calculator on that. Okay, now, one of the main things we want to do is try to interpret what's happening in context of the situation. So it's asking you, what do your answers in part A represent? So we're going to start by saying C of 10 represents. Okay, and C of 100 represents. And in our explanation, we want to make sure we include both the input and the output, okay, their numbers and their units along with what it means. So this value here, the money, is what it costs to produce. It says X yards of a certain fabric. Okay, so we can say C of 10 represents that it costs $1,532.10 to produce. And then we also want to make sure that we include the units. So it's 10 yards of fabric. Okay, so we have the cost and the units, the output and the units. And it doesn't matter what order you say them in. So if you want to say C of 10 represents for 10 yards of fabric, it costs $1,532.10 to produce, that is fine. Okay, and then for C of 100, that represents that it costs the $2,100 to produce, and that was 100 yards of fabric. Okay, and then I want you to do part C. So find C of 0, and I want you to think about what it represents, so we can come up with that together. Okay, so find C of 0, think about what that means in context of our situation. Okay, so when you plug in 0, the only thing you're left with is the constant, which is what? Yep, 1,500. Okay, and then, so what does this represent? Yeah, your base cost. Yep. So your initial cost, you could say, the cost of manufacturing, the startup. There's a lot of different ways that you can say that. Okay, so this represents the startup cost of manufacturing is 1,500. Okay, and that could be any number of things. Maybe you have machinery to buy to make the fabric, or a warehouse to rent to where you're going to produce it. Okay, for this particular situation, the startup cost is 1,500. Okay, now some of your equations are going to represent different values. So they might say they're like, what if where X is represented in hundreds? So this is saying, what if X represented the yards measured in hundreds? What would your answers in part A represent? So everything we did before, like the calculation, that would stay how it is. But for C of 10, now our value is going to be different. Oops, I was going to put a hole there. So for C of 10, the cost isn't going to change. The output, your Y, isn't going to change. It's going to cost the same amount to produce, and then we're going to find how many yards of fabric that would produce. I said, just give me 1 second. Oh, okay. Okay, and then for C of 100, it will cost 2,100 to produce. Yards of fabric. so let's say, what if X represented the yards measured in hundreds? So this is your X. If that is in hundreds, what you would have to do is take that input value and multiply it by 100. If it was in thousands, you'd multiply it by 1,000. Okay? So if something is measured in hundreds, you just have to multiply that, and the output's the same, but this is going to produce 1,000 yards of fabric. If it's 10 times 100, you just put the 2 zeros on the end. Okay, so can you guys do the second one? So your input's 100, but it's in hundreds, so we're going to multiply those together. Again, when you're multiplying that, you just, if there are 2 zeros here and 2 zeros here, you're going to have a total of 4 zeros. Then you just put your comma after the 3 from the back. So it should be 10,000 yards of fabric. Okay, so it doesn't change what you plug into your equation. It's only going to change what your answers represent. Okay,